We are moving to the next lab in the roadmap to the CCNA, and in this video we will discuss about static routing. Static routing is nothing but moving the traffic between two networks that are connected to the two different networks, and those are considered to be LAN network, and moving the traffic for one WAN network to another WAN network. Let's see the purpose of the lab. The purpose of the lab is to connect two routers together, and the next one configure the static routes so LANs can communicate each other from the other sides. To understand how a router forwards packets without dynamic routing. Dynamic routing contains what? OSPF, RIP, and BGP. What's the difference between dynamic and static routing? In a static routing, you by yourself specifying the route paths for between the each uh, WAN networks. With if we have a R1 and R1 having a 10.0.0.1 LAN network, and R2 having the LAN network 20.0.0.1, if you can ping and if you can assign IP address for both of the WAN and also assign IP address to the LAN, two of the LAN network, and if you ping both of the WAN network, it will communicate. But when you ping from R1 to R2 LAN network, it couldn't communicate because it doesn't have a LAN network road path in R2, so you need to specify routing path of the R2 LAN network in R1 WAN network. So let's see how it works in a logical overview by using the Cisco Packet Tracer, and I will give you a note what we have told up to now. What is static routing? Static routing is nothing but routing the traffic between two WAN networks that can make LAN network connected for the WAN network communicate each other on both sides. This is what we mean static network. In dynamic networking, we will have what we have in dynamic networking. We have OSPF and RIP in BGP. All the open shortest path first, router information protocol, and border gateway protocol. In a OSPF, you will define a OSPF to make a shortest path to choose to route the traffic, not manually. Because if you have a large network, you will choose dynamic routing, and if you have a small network, you will choose a static routing. Static routing is better for the smaller networks, small office networks like one or two networks. But if you have a large enterprise or MNC companies, and you have many branches that you want to communicate and connect between, so you will use a OSPF or RIP or border gateway protocol to route the traffic between all these multi areas. So uh, next, what we're going to do is to specify what's the purpose of our lab. To configure the route, configure the static route so that our LAN networks communicate each other on both sides together. And at the beginning we have forgot to specify to connect. Yeah, today we are learning a new thing to connect two routers together. If I'm getting any misspell, you can correct it. It will take a time for me to do all. And the top point we can do to understand how the router forwards packets without dynamic routing. I told you what's dynamic routing. The dynamic routing, that when you have a large network, you will use the dynamic routing to specify the routing in all of the interfaces. We will see in ongoing days, ongoing videos, on ongoing lab. So tomorrow we will see the OSPF mainly, how we will configure the OSPF when we have a large area network. And for now, let's see static routing, and let's move on to configuration of a Cisco Packet Tracer logical network. Let me open the Cisco Packet Tracer. I already created the topology, and let's see. Let's open the file. Here we need to do some corrections. Let's delete all these. Let's choose all at once. Delete all these. Let's see. Right now we have a clear view, and we have choose two routers because we need two different networks. These are two different networks, and this is one LAN network 10.1, and 20.1 is another LAN network, and the PC is configured with the IP address 10.2, and the PC2 is configured with the 20.2, and the router 1 is given by the IP address 172. It's a class B address because when you are taking the WAN connection, you are not giving the class C IP address, because you are directly communicating from the ISP. So ISP only gives you reserved IP address, not the local IP addresses like class C. Let we will see why we use 172 for outside of the network, and why we use 192 for the inside LAN network. And first of all, let's take logical devices. I'm choosing the model 2911. Two routers we need, and we have two routers right here. And next end device is PC 1 and 2, and the connections, let's choose depending on our topology we have created, and copper straight through for the different devices. Here we don't have a F0x1 fast Ethernet, so I'm taking gigabit Ethernet directly, and to connect to the fast Ethernet. Even you connect from the gigabit Ethernet, we only get access for the fast Ethernet. We don't be getting gigabit Ethernet fast network speed, because OPC only can access up to the 100 Mbps, 100 up to the 900 or hundreds of gigabytes, not in a 1 Gbps anymore. And let's connect the other one without having any extra more discussions into it. I am connecting 0 by 0, and The connections might be different from the topology we have created, or the network diagram that we have created, but it's all right. Whatever the interface you have chosen, it's all right. No more worries. And let's see if we can. No more connections. Here we directly can see the red color, that means the network is down. Let's configure the router. Initial dialog, no. Enter user execution mode, and let's check ISH in brief. Here we see what are all the uh, interface we have connected. For the WAN network, we have chosen 0 by 1. 0 by 1 is a down, and 0 by 0, 0 by 0 is down. No IP assign, and then let's assign IP address for the both of the interface. Let's go inside and let's do the first WAN address, gigabit ethernet 0/1, and let's assign IP address 172.168.1.1, and subnet mask 255.255.252. Let's explain why we use subnet mask 252 after we configuration IP address. First of all, let's do this 0/0 for the local area network, and let's set an IP address and 192.168.10.10.1, 255.255.255.0. It's easy to understand why we use subnet mask 255 and with a many hosts and 172 with a less host. It's easy. I will explain you in a minute. And here we see we have this connection up, but not this, because in WAN network we have to get IP address from the both of sides. And let's also configure the router to initial dialog no, and user execution no. Let's see SH IP in brief, no IP assign, and none of the interface is up. Let's configure the IP address right here, and let's go interface G0/1 and IP address 172.168.1.2, and then 255.255.255.252. Interface G0/0. Let's check again 0/0, and let's enter, and IP address 192.168.10, it's a different network, 20.20.1, and 255. You can also take 252 or 20, whatever, but in class C we don't be having any IP wastage, so better we choose 250 host and no shirt, no shirt. And let's see if we have here we see after configuring the both of the sites, we have the WAN network is also up, and LAN network is also up, and here first LAN network is also up. Let's try to ping from the router 1 to router 2 and router 2 LAN network. exit from here also. Just ping it 172.168.1.2, sorry, 1.1. Here we see we are getting a reply from the router 2, and let's try also 1.2. 1.2 is on old self, be- packet drop because it's looping the packet in our own network area. And so it will find a way to link up with the device, and when it asks for its MAC address, it will drop one packet, and in a reply it will send a newest packet. So the packet will be dropped, one packet will be burst, and the remaining four packets going from the next will get uh, the reply. So one packet drop. Let's try again and you will see 100%. Here see 100%. So let's try for the WAN network. For, let's try the LAN network of of the router 2. And now success rate is 0. And let's go to router 2 and let's try pinging from here to router 1 and router 1 LAN network. Exit from here, exit from here also. Let's ping 172.168.1.1. Here we're getting ping from its own self and also for the router 1 also. And let's ping for the router 190. I guess we have given the wrong IP address before, so let's write this is IP address of the router 1 LAN network, and we have given I guess 1.2 right here. So it's not a correct one. Let's ping 20.2. Here is 10.2. No success rate, and here also no success rate. Here also no success rate again. And let's configure the route, and me will explain the same command while configuring. Go to global configuration mode on T, and here you don't need to get any interface. You directly can add IP route IP address of the LAN network, I mean gateway or network ID. You will take network ID, not a gateway or anything. You will directly take a network ID 192.168. What's the LAN network ID 20.0, and subnet mask 255.255.255. So 0 255.0, and through which gate, through which uh, gateway or the router or the next interface or next hop it's the route is coming, which will be 172. It's a router 2 IP address 172.168.1.1, and invalid next hop IP address it will be 1.2 if not 1.1. And let's explain this IP route command. This would assign route to the LAN network of any other networks, and here we have given the route to 20.0 of the router 2, and here we given the subnet mask 22255.0, and through which router 2, router 2 IP address is 172.168.1.2, and we have given a route for the uh, router 2 LAN network. And let's check if we can ping uh, from PC2 to R1. Let's try ping 172.168.1.2. Sorry, we haven't configured IP address for the PCs first of all we have to configure the IP address. The piece is 192.168.20.2 and gateway. Copy and paste. Don't forget to change the last update 20.1. Right now we see here we go. After configure the IP address, we can get a reply from the router 1 and the same from the router 1 to PC2. Let's see. Exit from here and ping, sorry, paste, and here we see we are getting the ping for the PC2. And let's go to PC1 and configure IP address first. Let's say it's not a 20.2, let's change it to 10.2, and here we go. And don't forget to change it to 1, and it's also to 1, and close it. Get to router 2. How you give the, sorry, the sender to global configuration, and here we give IP route for the router 1 LAN area 192.168.10.0 and 255.255.255.0 and then 172.168.1.1. and yeah, we got route here and exit, and let's try pinging the router 1 LAN area. Ping, paste. It's not sorry right now. One packet drop because at the beginning router 2 doesn't know where is the PC PC1 will PC1 will be starting out, and then it will send a ICM packet, simple broadcast packet, and it will ask who is a PC1 with this IP address. And when the first packet reaches to the PC1, it will drop one packet and gives a reply to the second packet with its MAC address and whatever the source address or destination. It will reverse up, and from the next packet it will give your reply, so that one packet will be dropped and the next packet will be given. So out of 5 packets we will receive 4 packets. Let's try again. We will have a full conversation from next time, and it's 100% right now, and we are getting communication and everything is perfectly assigned. And let's try pinging R2 from PC1, paste 172.1.2, and we are getting reply from the router 2. Let's try for the PC2 directly in communication. Here we see we are getting reply from the PC2 also without dropping any packet, because we already wrote the traffic and ping from router 2 and router 1, and we have checked every LAN interface. It's already written the art table, so it doesn't have to look for the a new route. It already having the route to PC2, so it directly communicates without dropping any packet. So this is our lab for today, and I hope you all learn something, and hope you share support, and hope you give your happiness for the next video. And we will learn OSPF in the next video, and today we're ending up with this one, and I will uh, give all these resources like like this explanation and the packet package file of this Cisco Packet Tracer that we are given, this topology, and also this logical interface. Thank you.